Hi, this is section 6.2, trigonometric equations. So now we're going to solve equations that involve trig functions. So here it says find all solutions of the equation. So the key word is all. So that means there's going to be infinitely many solutions. The way I like to start these questions off is I notice that sine is isolated and it's equal to a negative value. So we know sine is negative in two quadrants. That would be quadrant 3. Negative, negative, and quadrant 4, positive, negative. Sine is the y-coordinate, and so that's why sine is negative in these two quadrants. So I'm going to draw an angle in those two quadrants. So I'm not sure exactly where the angle would be, but that's okay. As long as you just kind of realize that there's two angles in these two quadrants, one in each, that are going to be the solutions to this equation. So now let's look at a unit circle and let's find the angles who have a sine or a y-coordinate of negative radical 2 over 2. And since they don't really specify, you can choose degrees or radians. I personally like radians, so I'm going to go with the radians. So I found them here. It's 5/4 pi and 7/4 pi. So those are the two solutions, 5/4 pi, 7/4 pi. So x equals 5/4 pi. X also equals 7/4 pi. And because it says all solutions, that means we have to add all the any multiple of 2 pi, because if you go around again, that's another solution. If you keep going around and around, finding coterminal angles, you're going to get infinitely many solutions. So you would do that for both of these. And these are the two final answers. If you would have used degrees, then you would have said 360 times n. 360 times n. And you would have used degree measures instead of the radian measures. All right, for this one, let's do the same thing. But the first thing we need to do is isolate the trig function. We need to isolate the cosine. So we subtract 1, divide by 2. And now we've isolated the cosine function. And then the same thing as we did in the previous problem, you want to locate the two quadrants for which cosine is negative. Well, cosine is negative in quadrant 2 and also quadrant 3 because you have a negative positive and a negative negative, and cosine is the x-coordinate. So we need to find these two angles. So let's go ahead and do that. Let's find on a unit circle which angles have a cosine or x-coordinate of negative 1/2. That would be this one and this one. Let's do degrees this time. 120 and 240. 120 and 240. Okay. And same as before, you need to add any multiple of 60 to find all the coterminal angles. So 360 times n, 360 times n. Those are the two solution sets. All right, for the next problem, we have another cosine problem. And this time the angle is negative radical 2 over 2. So it's going to be the same two quadrants because cosine is negative in these two quadrants. So I will just draw that quickly. So we have two answers, one in this quadrant and one in this quadrant again. And so let's locate those. Cosine is already isolated. The difference is that the angle has a coefficient of 1/4. So let's see what that does to our solution set. So let's first find which angles have a x-coordinate of negative radical 2 over 2. That would be 3/4 and 5/4 pi. So 3/4, 5/4 pi. So 1/4 this time, x. The angle must equal 3/4 pi. And it also equal 5/4 pi. Those are the two. This is your 3/4 pi. This is your 5/4 pi. But you have to add any multiple of 2 pi, just like we did in the previous problems. And now the final step is to solve for x. So that means we're going to multiply both sides of the equation by by 4. for both of the equations to get x by itself. All right, so if you distribute, for the top equation, you should get x equals, notice that the 4's will cancel here. You'll have 3 pi plus 8 pi n. So 3 pi plus 8 pi n. And for the second set of solutions, you're going to get 4's canceling. You're going to get 5 pi plus 8 pi n. And those are your two solution sets. All right, let's go to the next page. They say find all the solutions of the equation that are in the interval. So this time they're giving us an interval to work with. So let's see what we should do. Cosine is isolated. Let's figure out what angle has a cosine value of 0, or angles. So looking at your unit circle, I see two angles. I see pi over 2, and I also see 3/2 pi. So let's use radians. In this case, we do have to use radians because the interval is in radians. So the argument, or the angle, must equal pi over 2, and it must also equal 3/2 pi. Whenever you get that, there is sort of a shortcut here. So the two angles that we're looking at are pi over 2 and 3/2 pi. Instead of writing two separate equations like we've been doing, what you can do is you can just write this equation, and then you can add pi n in order to take care of these solutions. So instead of adding 2 pi n like we usually do, when the answers or the angles are directly across from each other, then you can add pi n to get to the second set of solutions. So plus pi n instead of 2 pi n. But that only works when the two angles are directly across from each other. Yeah. All right, so now what we need to do is solve for x, and then we will be done. So, well, not quite, but we'll get to that step next. All right, the common denominator here is 4, so plus 2 plus 2. You're going to get 2x equals 3 pi over 4. So you got 2 pi plus 1 pi is 3 pi. All right, plus pi over n. And the final step is to divide everything by 2. When you divide by 2, that's the same thing as multiplying by a half. So we got our final answer will be x equals 3/8 pi plus pi over 2n. However, because we're working with an interval, you have to substitute values for n, starting with n equal to 0, then 1, then 2, ... until you have exceeded 2 pi. So what do I mean by that? Let's plug in 0 for n. So if you plug in 0, this term cancels and you just get 3/8 pi. So 3/8 pi, that's for the 0. Now let's plug in 1. If you plug in 1, you're going to get pi over 2 plus 3/8 pi. So I'm going to do some side work. 3/8 pi plus pi over 2. LCD is 8, so times 4 times 4. 3 plus 4 is 7 pi. 7/8 pi. So that takes care of the 1. And now we move on to 2. So now we're going to plug in 2 for n. Well, when you plug in 2, the 2's cancel, you just get pi. So you have 3/8 pi plus pi. Another way to write pi is 8 over 8. So now you have an LCD. 8 plus 3 is 11. So you have 11/8 pi. Notice that we have not exceeded 2 pi yet, because 2 pi would be 16 over 8. 16 over 8 is 2 pi. Then you can see a pattern emerge. So to get from 3 to 7, you add 4. To get from 7 to 11, you add 4. So the next term, you're just going to add 4 to the numerator. 11 plus 4 is 15/8. And we are still within the interval 2 pi, 0 to 2 pi, because 15 is still less than 16. But if you add 4 one more time, then you're going to get 19 over 8 pi, which is beyond 2 pi, so that's where you would stop. So there are only 4 solutions. So this one was n equals 0, n equal 1, n equal 2, n equal 3. So that's what you would have to do whenever they give you an interval to work with. So the next problem, so what you're supposed to do in this case, notice you have a square and a non-square. So you want to set the equation equal to 0 by adding 1 to both sides. So now you have 2 cosine squared t plus 3 cosine t plus 1 equals 0. And this is a trinomial that can be factored. So in order to factor this, you're going to have to do 2 cosine t times cosine t. In order to get 1, that's just going to be 1 times 1. And in order to get 3t, you have to add up the outer terms. So that's 1 cosine plus 2 cosine is 3 cosine. So that means that both of these are positives. All right, now you set these equal to 0, solve. Set this factor equal to 0, solve. Here you're going to get cosine t equals negative 1/2 if you subtract 1 divided by 2. Over here you'll just get cosine of t is equal to negative 1. So now you look at your unit circles. I'll start with this one. Which angle has a cosine value of negative 1? That would be right here, pi. So t equals pi. Over here, which angles have a cosine of negative 1/2? That would be this one and this one. So that would be 2/3 and 4/3 pi. 2/3 and 4/3. And these, we don't have to add 2 pi n because we're given an interval, and also there is no coefficient in front of the t's. So these are your answers. 3 answers total. All right, this last problem, notice you have a mixed match of trig functions, tangent and secant. So what we need to do is we need to convert this by using an identity in order to get tangent squared instead of secant squared. So go back to your trig formulas, and we're going to use this one here. So secant squared is equal to tan squared plus 1. So 2 tangent t minus secant squared is equal to t squared plus 1. You can verify that once again. Secant squared is equal to tangent squared plus 1. So that's what I did here. Now I have to distribute the negative. So if I do that, I'm going to get 2 tangent t minus tangent squared t minus 1 equals 0. Then I'm going to write this in standard form where I need this one to be positive. So I'm going to move that one over by adding it. Subtracting this one. And adding this one. So finally I end up with tangent squared t minus 2 tan t plus 1 equals 0. And now let's see if we can factor this trinomial. For sure we need tangent times tangent to get tangent squared. And to get 1, well, the only way to get 1 is 1 times 1. However, we do need the middle terms to add up to negative 2t. So t plus t has to be negative 2. And the only way that can happen is if these are both minus. Because a negative times a negative is a positive, and a negative plus a negative is a negative 2t, tan t. So now we can set these equal to 0. Since they're the same, that means you only need to really set one of them equal to 0. So you get tangent of t is equal to 1. If you look at your unit circle, there are 2 solutions where that is going to happen. The tangent is positive in 1 and 3. So plus plus, minus minus, clearly a positive divided by a positive is a positive, and also a negative divided by a negative is positive. So the two solutions, or the two angles who have a tangent of 1, would be pi over 4 and 5/4 pi. So pi over 4, 5/4 pi, and that is the end of the section.